Hello guys, in today's grade 12 mathematics sequences and series exam clinic, we are looking at the Department of Basic Education's mathematics paper 1 of May 2025. The sequences and series questions on this exam paper were question 2 and 3. There were questions 2 and 3. So you remember, guys, that in your exams, for every mark, you should spend a minute. So 1 mark, 1 minute. This question here, question 2, is 18 marks. You should spend 18 minutes. Question 3 is 9 marks. So you should spend 9 minutes. In total, for these 2 questions, we should be spending 27 minutes and no more than that. All right, unless if it's very difficult. And what I will be doing, in as much as I will be showing you how to answer these questions, I will also be explaining some other things that may need some explanations. So, without any waste of time, let's get into it. Let's start with question 2. So, question 2 says, given the arithmetic series 5 plus 7 plus 9 plus and so on, with the last term being 93, 2.1.1. 2.1.1, determine the general series Tn in the form T sub n equals Pn plus Q. Cool. So we have, let's see, we have 5 plus 7 plus whatever. So we can say, as you can see here, A equals 5, that is the first term. And then D equals T2 minus T1 or T3 minus T2. And this is 5 minus 7, right? Which is equal to 2. So we know general term is T sub n equals A plus, open bracket, n minus 1 times D, right? Now, T sub n will be, the value of A is 5, the value of n is unknown for now, the value of D is 2, and this says we have 5 plus 2n minus 2, therefore T sub n equals 2n plus 3. Indeed, it is in the form Pn plus Q. Remember, we were supposed to spend a minute in this question. All right, now let's go to the next question. 2.1.2. So 2.1.2 says the given series represents the number of kilometers that an athlete ran each week in preparation for an ultra marathon. The athlete ran 93 kilometers in the last week of the training program. How long in weeks was the training program? So remember, each term that you're seeing here represents the number of kilometers this athlete ran in kilometers, right? So this is week 1, week 2, week 3. All right, so let's see now. They're asking us how long in weeks was the training program. So we need to know what term number is 93. So let's get into it. T sub n equals 2n plus 3. So Tn is 93, right? Now this becomes 90 equals 2n. Therefore, n will be 90 divided by 2, meaning n is 45. All right, n is 45. So this therefore means the training program was 45 weeks, isn't it? The program was 45 weeks, right? Perfect. Now let's go to 2.1.3. The athlete used this opportunity to raise funds for her high school The community sponsored her 10 runs for each kilometer run during the training program. Calculate the total amount that the athlete raised for her school. So remember, for each kilometer run, the community sponsored her 10 runs. So let's see how many kilometers she ran in total. All right, let's see how many kilometers she ran in total. So we will say sum of terms equals, we have the first term and the last term. So we can use this formula here, n over 2 into first term plus last term. Okay, you can use this one, or you can use the general or the other arithmetic series formula. It's up to you, but I will use this one. So there was 45 weeks in total. So where that's n, we put 45. Kilometers spent on the first week was 5. Kilometers ran on the last week was 45, right? So let's get into it. Now, what do we get? Oh, no, sorry, not 45. My mistake. Kilometers that were ran in the last week were 93, sorry. Were 93, isn't it? First term is 5, last term is 93. So let's get into it. 45, 45, open bracket 5 plus 98, close. No, not 5 plus 98. 45, open bracket 98, all over 2 is 2,205. So this is 2,205 kilometers. All right. So total amount raised. So total amount raised, let's see, equals, I'm going to say this, 10 rands per kilometer multiplied by 2,205 kilometers. Do you guys see this? The reason I added this is because I want you to understand that the kilometers are cancelling. And when you look at it, ooh, this will now become 22,000, right? It will become 22,050 rands. This is the amount that was raised. Right? This is the amount that was raised. Okay? Perfect. Now, 2.2. 2.2, the general term of a geometric sequence is t sub n equals 2 to the n plus 2. Write down the first term, 2.2.1a. The first term will be t1 equals 2 to the power 1 plus 2. This becomes 8, isn't it? This becomes 8. B, the common ratio. Common ratio, guys, you can see that it is simply 2. You don't have to find it. So R equals constant. Yeah, why are they saying common? Constant ratio, it's fine, is 2. Okay, it's 2. You can see it here. All right, it's 2. Moving on, 2.2.2. Calculate T20. Write your answer as a power of 4. Right. So remember, we have Tn equals 2 to the power n plus 2. Now we're looking for T20. So T20, where there's n, we will put 20. Right? This becomes 22. So 22, we can say, let's take 2 as a common factor here. So if we take 2 as a common factor, or rather we factor out 2, it will become 2 times 10 times 11, in fact, right? 22 divided by 2 is 11, right? Is 11. So we can try it in this way, 22, 2 times 11, right? So we can now say we have 2 to the 2 like this, and then raised to the power 11. 2 to the power 2 is 4. Now this is what the question required you to do, right? This is a power of 4. All right. This is a power of 4. All right. Perfect. Now, 2.2.3, let's get to it. 2.2.3. 2.2.3, we have this sigma here. We have this sigma here. So you see, they say we must calculate this sigma from n equals 1 to 1 over t sub n. So this is basically the sum of, to infinity. Do you see this? It's basically the sum to infinity. So what we need to do now is this. We are basically saying our series, our series is 1 over tn. If you like, you can just do this. It'll be 1 over 8, right? Let me just write it in this way. It is equal to 1 over 8. And here where there's n, we started with 1. 1 plus 2 is 3. 2 to the 3 is 8. Then where there's n, you will put 2. So it'll become 1 over 2 plus 2 is 4. So 2 to the 4 is 16. And then it'll become, it seems like it'll be 32, right? 1 over 32, right? This is your series. Now, when you look at it here, you can see what your A is, right? Your A is 1 over 8. And then what is your R? Your R is 1 over 16 over 1 over 8. And this gives you half, isn't it? This gives you half, right? It gives you half. So now you can find the sum to infinity, right? You can find the sum to infinity. Sum to infinity is A over 1 minus R. The value of A is 1 over 8 over 1 minus R. R is half. You have a calculator, you can get your value there. You will realize that you are getting 1 over 4, which is similar to saying 0.25. All right, which is 0.25. If you are wondering why did I use sum to infinity, it's because the number of terms here are adding up to infinity. All right, so this question wants you to use sum to infinity. All right, perfect. Now, 2.2.4, they say consider the first 21 terms of the sequence. Calculate the sum of the series in this sequence that are not powers of 4. Wow. Those that are not powers of 4, it's going to be interesting, right? Those that are not powers of 4. So just say this. Terms that are not powers of 4 are odd number terms. Okay, are odd number terms. I.e., guys, means that is, okay, that is term 1, term 2, not 3, sorry, not 2, term 3, term 4, why am I saying 4? Term 5, odd numbers, right? Term 5, and then, and so on until, let's say, term 21, right? Until term 21. Do you guys see this? This will be our terms that are not powers of 4. All right. So now what we are going to do now, we can do it in this way. We can say here we're looking at, when you look at it, remember, note general term is 2 to the power n plus 2. Therefore, the series of odd numbers, okay, of odd number terms is 2 to the 1 plus what? 2 to the 1 plus 2 plus 2 to the 3 plus 2 plus 2 to the 5 plus 2 and so on until 2 to the 21, right? Plus 2. And this is the same as saying 2 to the 8 plus 2 to the 5 plus 2 to the 7 and so on until plus 2 to the 23, right? So if you want to know the number of terms, there will be 11 terms, right? There are 11 terms. I'm explaining here, guys. You can also write your answers in this way, but I would do it shorter. But here, because I'm explaining, I have to go this way. There are 11 terms, okay? There are 11 terms. So once again, what is our R? R is 2 to the 5 over 2 to the 3. My mistake, let me fix this. 2 to the 5 over 2 to the 3. This will become 4, right? So let's find our number of terms. Our number of terms will be A into, not number of terms, sum of the first terms. We said we have 11 terms. So this will be sum of 11 terms equals the first term is 2 to the 3. Even if you write it like this, it's okay. You guys have calculators. 2 to the 3. And what is the first term? It is 4. No worries. How many terms? We're looking at 11 minus 1, close all over, 4 minus 1. Let's see. 2 to the 3, open bracket, 4 to the 11 minus 1, close all over 3. What are we getting? We're getting sum of terms being 11,184,808. That is the sum of the terms in this sequence that are not powers of 4. Do you guys see this? Oh yeah. So these were explanations. If you like, in your exam answer book, you can write it down. It's okay. All right. Remember, there is an instruction. There is an instruction. Let me show you. There is an instruction that says, if necessary, no. Okay, clearly show all calculations, diagrams, graphs, etc., which you have used in determining your answers. This is what I did. Okay? All right. All right, let's proceed now. Let's proceed now. We are going to question 3. Okay, we are going to question 3 now. So we finished this question in 18 minutes. Now we are going to question 3. We must finish it in 9 minutes or less. The question 3, given the geometric sequence 14, 9, 6, 5, show that the general term is t sub n equals n squared minus 8n plus 1. Cool. We will say this is 14, 9, 6, 5, and so on. 9 minus 14 is minus 5. 6 minus 9 is minus 3. 5 minus 6 is minus 1. Minus 3 minus negative 5 will be positive 2, isn't it? It will be positive 2. Negative 1 minus negative 3 will be positive 2. So we know to get a quadratic equation, we must say t sub n equals an squared plus bn plus c. And we know this term here is 2a, this one here is 3a plus b, and the first one is a plus b plus c. Now let's go. 2a equals 2. This implies a equals 1. 3a plus b equals a negative 5. We said a is positive 1. Right? So 3 plus b equals negative 5. This implies b is negative 8. A plus B plus C equals 14. A was 1, B was negative 8, plus C equals 14. So I see we will be saying 14 plus 7 will be 21. Right, will be 21. Therefore, T sub n equals n squared. The value of B is negative 8, so minus 8n. The value of C is positive 21. So we have proved this, isn't it? Cool. Let's go. 3.2. So 3.2, let's see. So 3.2 says the two consecutive terms of the quadratic sequence have a difference of 33. I hope you guys are getting this. So we can be saying here, let's say the bigger term is called T1 and the term before it, sorry, Tn, and the term before it, we will call it Tn minus 1. Their difference must be 33. All right, this is what they say. All right, this is what they say. Two consecutive terms. So let me show you. This term is Tn, this one is Tn minus 1. If n is 2, obviously Tn minus 1, where n is 2, will be T1. You get it? Oh yeah. Right, let's see now. Let's see now. So what we have, we know what our Tn is, so we'll write them as they are. That is, Tn is n squared minus 8n plus 21 minus n minus 1. Where there's n, we will put n minus 1. All right? So n minus 1 square minus 8 into n minus 1 close plus 21 close equals 33. Let's see. N squared minus 8n plus 21 minus, open bracket, n squared minus 2n plus 1 minus 8n plus 8 plus 21 close equals 33. Once again, n squared minus 8n plus 21 minus, open bracket, n squared minus 10, isn't it? Minus 10n, and I see here, plus 30 close equals 33. So we have n squared minus 8n plus 21 minus n squared plus 10n minus 30, and then minus, no, let me not say minus, and then equals 33. The n squared terms are cancelling. Negative 8n plus 10n, we will be left with 2n. And then positive 21 minus 30 will be, it seems like it'll be negative 9. Negative 9 equals 33. If you like, you can say 2n. 2n. Oh boy. So 2n equals 42. 33 plus 9 is 42. N equals 21. Right? So the value of n is 21. However, the question said, calculate the value of the larger term. The larger term is Tn. So larger term Tn is T21 will be 21 squared minus 8 into 21 plus 21. Right? And what are you getting? Let's see. 21 squared minus 8 times 21 plus 21. You are getting 294. 294 is your answer. Okay, 291 is your answer. All right, that is it. Now, let's go to 3.3. 3.3 the value of m is added to each term in the, this is interesting, guys. The value of m is added to each term in the quadratic sequence. Determine the values of m for which only the terms between t1 and t7 of the quadratic sequence will have negative values. I want you guys to see something, okay? I want you guys to see something. In our sequence, the sequence, I'm going to write it here. The sequence was 14, 9, 6, 5. The difference was -5, -3, -1. If you can see, the difference is 1, 1, 1, 2, 2, 2, 2, 2, 2. So this is 2, this is 2, this is 2, and it means this time here, it means this term here will be 1. Now, 5 plus 1 is 6, right? And then 1 plus 2 is 3. 6 plus 3 is 9. And then add 2. 2 plus 3 is 5. 5 plus 9 is 14, isn't it? How many terms are here? 1, 2, 3, 4, 5, 6, 7. All right, cool. Now, they are saying to us, determine the values of m for which only the terms between t1 and t7 of the quadratic sequence will have negative values, right? Will have negative values. All right. So let's see this. Okay, let's see this. Wow, they're saying is added to each term. Determine the values of m for which only the terms between t1 and whatever will have negative values. So which ones will really have negative values? Now, what I want you to see is this. What I want you to see is this. Okay, what I want you to see now is this. Let's proceed. Let's proceed. Okay, so when you look at this sequence, they are saying when we add m to these terms, we will have negative values. Now, what I am seeing here, for example, I want you to see this. Term 1 of the quadratic sequence is the same as term 7. Do you guys see that? Do you guys see that? In the same way, we will say, I want you to also see term 2 is the same as term 6, isn't it? Now, what is term 1 and term 7? Let me just leave a space. Term 1 equals term 7. So what is term 1? It's 14. And what is term 2? It's 9. So is term 6. Right? Right? So remember, they're saying when you add m, this will be negative values. Right? When you add m, these will be negative values. So let's try this. I'm going to say adding m. Okay, adding m for both of them, guys. Okay, adding m for both of them. When I add m to term 1, or term 7, okay, what will we get when we add 1? What will we get? I do not know. Let's say the value will be positive. All right, when we add m, let's say the value will be positive. Right, now check this one out. You said term 1 is 14. Now m is still unknown, so m is greater than negative 14. Right? M is greater than negative 14. Just hold on. Now let's add m on this. So this we can say, once again, let's just say term 2 plus m. Okay? For this one, because it's smaller than 14, let's say smaller than 0. Okay? And then what do we get? We will get 9 plus m is less than 0, right? So this will be m is less than negative 9, right? M is less than negative 9. So this, for it to work, let's look at this one here. For it to work, it will not necessarily require that M must be, it will not require that M must be exactly greater than 0, right? It can also be equal to, okay? It can also be equal to. So combining these two conditions, you can therefore conclude and say, this is when M, the smaller value between the two, is 14. So when M is greater or equal to negative 14, but less than negative 9, these are the values of M that will give you negative values. Okay, these are the values of M that will give negative values. I will make a video on this that you will see that's focusing only on this particular topic. Okay, or rather on this particular question. So with that being said, it's a wrap and bye-bye.